What is up, guys? Welcome back to my channel and welcome to my fourth video. In today's video we're going to be talking about the delay function, so delay in milliseconds, delay in microsecond, and then also finding system time in microseconds and system time in milliseconds. I will kind of give a little disclaimer to this video in that this video is going to be less explaining how these functions work and more explaining how to implement them into your code and what it looks like. A lot of these functions I did not write myself. None of these functions I actually wrote myself. These are all taken either from AQ32, which is the firmware that I talked about in my first video, which is another kind of pretty bare bones drone firmware, as well as I also have the code up for Betaflight right here, and Betaflight also has some pretty similar functionalities in terms of implementing the delay functions. I can try and make this video pretty quick just because I don't want to try to pretend to know stuff that I don't. But here's what we're going to be talking about. So the first function is the micros function. Millisecond function gets system time in milliseconds, delay microsecond, and delay milliseconds. And we have an initialization function as well, which is down here, and it's called cycle counter init. So first thing we want to do is have this global variable called USTix, which is static volatile UN32, so static local to just this file. Volatile means it can be changed anywhere. 32-bit integer USTix, and then we also have these other two variables, systic uptime and systic cycle counter. We'll see where those come into play as well. So we're going to initialize USTix as the system core clock frequency, which should be set to 216 million for us, and that gets set after we set the time of the clock. So right here, 216 million. And then we're going to set these two registers as well. And if you want like a little more of an in-depth explanation to how this works, and I apologize in advance because I know this channel is supposed to be really getting into how everything works at a low level, but some of these things I don't really want to belabor too much. These essentially are debug registers, and they're really only accessed if you want to do like certain types of hardware debugging. And the delay function essentially uses these debug registers and takes advantage of them in this interesting way that the HAL libraries don't do this, but there are kind of these workarounds that people have figured out how to do these delays at a microsecond level. So DW2 is data watch point trigger, so you have to essentially enable the cycle counter and then kind of enable the core debug register here as well. So this is going to be common to all STM32 devices and probably even all ARM Cortex devices as well. So initialize it here, cycle counter init, and then if we go back up to our functions, we have microsecond, and this isn't how it's implemented in Betaflight, but here it is here, and it uses some assembly functions, which I'm not going to try to explain how they work. I don't really know assembly that well, so I'm going to just kind of have to take this at face value. So systic uptime, so that's the variable that I showed initialized at the top, and this gets updated in the systic handler function. So systic handler is right here, and systic uptime, every time it gets run you do plus plus, so you add 1 to it, and then the systic cycle counter equals data watch point trigger cycle counter register. Again, not going to try to explain how this works, but this is what you need to do to implement this function. And then going back down to get the system time microseconds, looks like this. Milliseconds returns the systic uptime. This one I can explain how it works. I mean, the systic handler function gets called once every millisecond. So every millisecond this thing goes up. So you kind of just get the time, get this variable at whatever time you call it, and then however many milliseconds later you call it again, it's going to be kind of the updated milliseconds of the function. So that one's pretty easy to understand. And then delay microseconds. This is what it looks like here. Run that, and then delay milliseconds essentially runs delay microseconds, but 1,000. So it runs the microsecond delay however many times you need for the millisecond delay. So this is going to be our essential implementation of a delay function. And then another thing I kind of want to mention is that you're never going to use a delay function inside of the main loop that you're running. So inside your while one, you never want to run delays. Most people probably are familiar with this concept, but you never really want to run delays inside a function because it usually causes like desynchronization. So say like you want your program to execute once every millisecond. You might say, okay, I'll just run everything, run all my functions, then do delay 1 millisecond, and then run everything again. But your program, your functions that you're running take actual time to run as well. So say the functions take, say, 20 microseconds to run, and then you delay for a millisecond, and then you go back to the beginning. Now, the entire function program time to get from top to bottom takes 20 microseconds plus 1 millisecond, so now you have 1.02 milliseconds. And then the next time you run through, it's another 1.02 milliseconds. So now you have 2.04 milliseconds. And this keeps on gradually getting worse and worse. And if you're running this 1,000 times a second, then everything's going to be out of sync. And you're no longer going to be running things at a 1 kilohertz rate. So it's important to only use these delay functions when you're when your main loop is paused, or when you're inside initialization functions. So say you want to initialize the MPU 6000, you know that whenever you reset it, it takes 3 milliseconds to start back up again. So that's when you would implement the delay function. But inside the while one loop, you never really want to implement that. You only want to call stuff through interrupt handlers. So that's going to be all for this video. Again, I'm going to link this in the description. Hopefully this can kind of give you a better idea of how this stuff sort of works, and you can throw in your code as well. So that is all for this video, and I'll see you soon. Next video is probably going to be on the RCC, or the reset and clock configuration, and how to set our clock to 216 megahertz. See you all soon.